Hi, today we will learn how to solve a related rates problem step by step. The people who will be explaining the problem are our friend William Cham, yes, and our friend Andrea Reina. Yes, you heard it right. Before we begin to solve our beautiful problem, there's some essential things we need and must know. Yes, my friends, must. Starting with basic algebra. We use this every single day of our lives. Rules of derivatives. We can't forget our rules. If we forget them, then we're screwed for the rest of our lives. Following with basic geometry, and last but not least, how to use a calculator. It doesn't matter if it's a modern calculator or a 1960s calculator. So let's see the problem. Water, yes, H2O, water, is pumped at a uniform rate of 2 liters per minute into a tank shaped like a frustum of a right circular cone. The tank has an altitude of 80 centimeters and lower and upper radii of 20 and 40 centimeters, respectively. How fast is the water level rising when the depth of the water is 30 centimeters? There's a process that must be done in order to get the right answer. The first step of our problem is to draw the diagram. The diagram will help us know what the problem is asking for. We will be a little bit more clear on what we are going to look for. In this case, we're looking for the rate because it's saying how fast is the water level rising when the depth of the water is 30 centimeters. How fast? There's R1 that's 20 centimeters, and there's R2 that's 40 centimeters, and there's our height. The step number 2 for our problem is to set up the givens and the missing variables. Our first given is the rate of the volume, which is 2 liters per minute, but because the other two givens are in centimeters, we must change this to cubic centimeters by multiplying 2 times 1000, which will give us 2000 cubic centimeters per minute. R1 is 20 centimeters, R2 is 40 centimeters. Recall that we must work with the same SI unit. Remember that the other two givens are in centimeters, so we changed 2 liters to 2000 cubic centimeters per minute. Our unknown is the rate of the water level rising when the depth of the water is 30 centimeters. So step number 3 is to find an equation or formula that relates all the variables. In this case, we use the volume of a frustum of a circular cone. That's equal to 1/3 pi h times a squared plus ab plus b squared. There is our givens, our known, and our formula. And this is an essential school supply, an essential life supply, an essential everything. This is so important. You must have it, you must use it. Okay? You need it. If you want to get it at first, then don't get distracted, please. So we look for B using triangle similarity, also known as proportionality. Yes, friends, yes. Back to 9th grade geometry class. Oh yeah. Remember that we must find B. We don't know what is B. We want to know what is B so we can replace it in the original formula. So we do ratio h over x is equal to 80 over 20. You do the cross product and there's 20h equals 80x, and then you solve for x, and after that you just simplify, and yeah, you already find x. Then you replace it in the formula for b. That's b equals 20 plus x, but you already find x, so you replace it in the formula. You would have 20 plus 1 over 4h. The procedure is a little bit long, but if you do it step by step, then it's going to be easier. So we replace the given variables, that's 20 squared plus 20 times 20 plus h over 4 plus 20 plus h over 4 to the square, that's sum of squares. And yeah, we just solve it and we have as a result 400 plus 10h plus h squared over 16. The rest is just adding, multiplying, and as a answer for a squared plus ab plus b squared is 1200 plus 15h plus h squared over 16. So we just replaced it. V is equal to 1 over 3 by h times 100 to 1000 plus 15h plus h squared over 16. We multiplied h, the one that's outside the parentheses, by every single term inside the parentheses, and we multiplied the 1 over 3 times every single term in the parentheses. Now it's time to derivate. Yes, it's time for the fun. Oh yeah, it's time for the fun. Oh yeah. So we derivate by using implicit differentiation, that is to derivate both sides of the equation. In the right side, as you could see, every single term was multiplying by dh dt. We factor that out so we can solve for dh dt. Then we passed all the parentheses, dividing dv dt, and yeah, we just substitute the given variables and calculator, and voila, magic. And as I said before, replace the given variables in the original equation. We get 2000 cubic centimeters per minute over pi times 400 plus 10 times 30 plus 3 times 30 squared over 48. You must know the rules of fractions. You must know them. The division, the addition and subtraction, all of them. Remember that when you divide fractions, you must do the reciprocal. If not, you're going to get a wrong answer. Okay? So the final answer is 0.84 centimeters per minute. Thanks for watching.